Alrighty, welcome today to the last of the DAT prep sessions. We're going to be talking about the PAT section, that wonderful section where you do 90 questions in 60 minutes. So you're going to be averaging about 2/3 of a second, or 2/3 of a second, 2/3 of a minute per question. There's good times to use that time, and there's other times where you should just be answering things boom, 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 boom. So have either of you guys actually done a PAT section before? No. Okay. So it's different. You definitely don't want to go in cold to something like this for the real test. So you want to make sure you're doing a lot of practice with this perceptual ability. If there is one thing to do more than the other sections, I would say this is it, because it's such a different kind of experience. So what that comes from is the fact that the questions are unique. So let's go through some techniques for each of the types of questions that you're going to run into. The questions are 6 types. So you get 15 questions of each type in this order. And it'll always be in this order. You're going to start with apertures, going to go to view recognition, go to angle discrimination, then paper folding, then cube counting, then 3D form development. So let's look at the apertures, or what a lot of outlets will call the keyhole type questions. So what you're looking at here is they're going to give you an object. They're going to give it in this orthographic view where you've got the top side, the front side, and the end side. We usually will, in DAT parlance, refer to this as top, front, end view, like that. So the end is referring to this face, the front is referring to this face, and the top is referring to this face. And presumably, you'd think this could be symmetrical, but it does not have to be symmetrical. The things that you don't see do not actually have to be symmetrical to the things that you do see. So that's one of the things you want to remember about these things. Basically, each of the keyholes, the apertures, is going to relate to one of those views, be it the top view, the front view, or the end view. And you have to, number one, decide which one it is before you can decide, does this object fit? And it will be a perfect fit. It won't be that you could put it through a giant hole, even though it would fit, that's still not a match. So it has to fit nicely, exact fit into that hole. So like square peg, square hole kind of thing. There can be no twisting. You can't, once you get it in there, you can't twist it to the side. So I like to think of these as the human Tetris games. Like if you've seen those on YouTube videos or whatever, the person has to put themselves in a position as the wall passes through. That's what this is. You know, put the object in the position and the wall will pass across it. And if it passes perfectly, then that's the right fit. So there's no weird stuff in the objects. Notice that next statement there says there's no irregularities. So it's not going to be like there's going to be some weird funky zigzag where you can't see it. There might be like some asymmetry there, but it doesn't have to be, it won't be a perfect match necessarily, but it won't be something ridiculous that doesn't show up. The objects and the apertures are drawn to scale. So you got to get used to scale on this and make some decisions with that. And there's only ever one correct answer. So one of the techniques I like to use on this is just first off, figure out one of the views. So like if I'm looking at A, what other answer choice does A line up with as far as the view that we're looking at? A is a top view. What other one is a top view? C would be the top view. B or E, they're not top view, they're front view, but they do pair up with each other. So I'm going to select top. Since that's the first one that popped out at me, I'm going to select the top. Between A and C, which one of those just doesn't work and why? So you want to compare contrast, and that's why we pick a view. Look at the differences between the two. Don't look at the absolutes. What's different about A and C? Well, the direction doesn't matter because I could rotate C in my mind's eye and I would get it to look like A. But yeah, it's that sharp part. That's the biggest distinction right here. In this one, the pointy object is not flush. In this one, it's flush with the edge, right? So by identifying a difference, it gives me something to look for in the original structure. Does it look like it should be flush, or does it look like the point is sticking out farther than the end of the object in the original view? I.e., which answer choice is the bad one? Is it A or C? It's going to be flush, actually. A is the good one because looking at this edge on, this is not sticking out so far as to be not flush. We can actually get rid of C. And how do I know that? Because this is my experience. This is why you've got to do a lot of these, tons and tons of practice, because when I'm looking at that figure, now I can see what they're asking me to see. And part of the DAT is just be able to look at that and go, yeah, it's not pointy outy enough. The slope is wrong. It doesn't slope that much back here. So I was actually looking at this inside slope too. That looks far more like the triangle here than the triangle there, because that's a really tight triangle. So we can get rid of C. And then switch to a different view. Be able to compare and contrast. Actually, these are both end views. Sorry about that. That should have been end view. So I'm gonna look at the end view. What are some differences in the end view? That notch there, like this thing? Yeah, I agree. So which one of those looks to be too big or too small? B looks a little too small. Does E look correct? Or is there something else we could look at E for? Yeah, I honestly think E also looks too tall. I think that one looks taller than that one. This one's got a thicker gap in there. This one just comes right up in there. So I would get rid of E for this one as well. And then look at D. What view does that one associate with? We only got one left. Yeah, that's the front end, we would call it, not the bottom, but the front, because just the way they orient it, it's just the DAT standard. So we look at that front end. Does that look like it matches? Kind of, yeah. Is there anything that we can identify on that thing? Like what I'm looking at is here, this distance. Does that seem like the same distance there as it does here? Yeah, those don't look the same. I think this one's got too big of a distance. D's out, A is our best answer. And those are the judgment calls you have to make with these things. But to get yourself started, what you got to do is make a decision of what view it should be matching with. And then you have to, like, doing compare contrast is a surefire way to look for problems. And then at some point, though, you just got to start making decisions. And that's just the way of it. So these are problems that I think these are one of the ones that people feel are the hardest, along with the next type, which is the orthographic projections. The orthographic projections, you're looking at it top, front, end again, but now you're looking at it in a different way. So you have to take the types of projections that they're giving you and then figure out what the third projection is. So that it's top, front, that you got to figure out end. If it's end, front, that you got to figure out top, and so on and so forth. So there's a couple rules about these things you got to remember. So dashed lines, that means there's some kind of hidden feature. Most notably, it's probably something that's it's an object or a hole that's in the center of the thing, or it's a void in behind it. Again, there's no like hidden weirdnesses with these things. They're not going to do some kind of like zigzaggy thing on the parts you can't see. Projections are drawn to scale, and there's only ever one correct answer again. So there's a couple ways to get started. And this first one works on some of the easier questions, and it's nice to get yourself started on pretty much every question. And this is what we call the horizontal or vertical and curved line tests. So if I look at that top view, there's some vertical lines, and I look at the front view, there's some vertical lines. Those have to line up. So in the top view, how many vertical features are there? There's 5. And in the front view, how many vertical features are there? There's actually 4. Or sorry, 5, I mean. The power of suggestibility. See that hidden one though? Because I think that's the one people forget to count right here. That is also a vertical feature. That's why it's a dashed line in the top view, because it's hidden underneath that overhang. So, and we know that has to be the case because it's got to line up. The vertical lines have to match. Well, so do the horizontal features when going from front to end. So front to end, I have to have horizontal features which can line up. So how many horizontal features should I see in this thing? 1, 2, it looks like those are at a different level. 3, 4, 5. So how many must I have to have in my end view, which is what these guys are? I have to have 5 as well. So which 2 answers don't have, well, actually I'd say they all have, which one answer does not have 5 vertical, or sorry, which one answer does not have 5 horizontal features in it? Answer choice A does not. It's only got 4. 1, 2, 3, 4. So answer choice A is gone. We can get rid of that one. D also has a problem. What's wrong with D? One of the horizontal features is in the wrong place. That's what I would be saying. And that means that cylinder is too tall, because now I have 5 vertical or horizontal features, but that thing is not supposed to be there. Whoops. Did you guys see anything change on the slides? Oh, crap. I've got a problem. Okay, so at least you guys can still see the slides. That's good. Something weird happened here on my end. Okay, so that means we can get rid of D as well. Boom. The curved line test, what I mean by that is features in the top view have to curve around to be features in the end view. So the horizontal become vertical and vice versa. So 1, 2, 3, 4, and we can see in this case it matches. So B and C both share those features. Now we got to decide between B and C. So now compare, contrast the two. What's different between the ones I have left over? Whether or not you can see the cylinder. So now this requires you to understand how these things are rotated. So to go from top view to front view, or actually let's go front view to top view. What we do is we take the back end of the front view and we flip it up so that we get the top view. But to go from front view to get the end view, we take the back end and flip it to the right. So should I be able to see that cylinder or not? We're taking the back of it, moving it to the right. I should be able to see it because I'm rotating it from above clockwise, rotating it from above clockwise. So that means B is my best answer here. Now, this means you have to have an intimate familiarity with what the rules are of rotation here, which is why you want to get a good prep book on this that will help you understand what way these things are being rotated. And because if you look at the rotation badly, if you take the back end and flip it left, then you're going to think C is the right answer because C would be correct in that case. So you have to understand those rotations and explicitly be able to move that thing in your mind in space. Boy, this is an annoying part of the test. So that's what I think makes these two types of questions probably the hardest, because you have to think, you have to know the rules of the questions very, very well. This kind of question, the rule of the question is very simple. What are you supposed to do with these 4 angles? Least to greatest. Least to greatest. And they don't tell you that part. they give you these numbers. They don't do less than or greater than signs. So the first thing that is easiest to start with is just look for the largest, look for the smallest. Get started that way. I think the largest is pretty straightforward in this one to figure out. Which one's the largest? 4. So we can get rid of which answer choice. That means B is out. Just get rid of that puppy. All right. Now, I think the next easiest is actually to look for the smallest. Which answer is the smallest here? Or which angle is the smallest, I should say. 3 is smaller than 2 or 1. Oh, look at that. Wouldn't you know it? That gets rid of D, that gets rid of A, then it means our answer is C. Are they always going to be that easy? Oh, heck no. But let's use this to our advantage. Which one's bigger, 1 or 2? Well, if you're like me, you look at those 2 angles and you go, aren't those the same? So how do you get better at doing this? Now, what's the one notable thing I said in the rules on the left side? What can you not do? Can't hold up anything or touch the computer screen, because then you will be disqualified. You do not want to get yourself doing that, so you can't practice that way. So there's 2 things that I've found work for many students. Number 1, if you guys remember those old 3D posters that used to be around where you'd like unfocus your eyes and you'd be able to see the 3D picture. If you can do that at will, you can actually overlap the angles with each other. So what I'm doing right now is I'm unfocusing my eyes and I'm looking at 1 and 2, one with my left eye, one with my right eye, and letting them defocus so that they overlap. And when you get them to overlap, all of a sudden, voila, 2 is distinctly smaller than 1 because I'm seeing now the angles on top of each other. Now, that's a trick that you have to train yourself to do. And actually, those 3D posters are helpful to do that because they can teach you at will to defocus your eyes. I don't know if you guys are able to do that because one of the things I also find is the younger you are, the harder it is to do that because your eyes work better. So my old eyes can defocus really easily because my muscles aren't as strong. So that's one way to do it. The other thing to do it is to compare to some reference angles. And where can I get reference angles that are right nearby? What reference angle is that? That's a 90-degree angle. So I can use that and estimate how 2 relates to 90 and also how 1 relates to 90. And I would use this one for my reference for 1 because it's closer. Or if it's an obtuse angle, then I can just use like a straight line all the way across. What's that reference angle? That's 180 degrees. So I can use those nearby reference angles to help do comparisons. And then some people, they just, I don't know what it is. They can just look at those things and go, yeah, that one's bigger. I mean, do either of you have an easy time 2 is smaller than 1? Just looking at it straight away. I'm always curious to find the people that can do that. You can? Wow, I'm like blown away. Like I find that very difficult to do just by eyeballing it. That's why I have to make the comparisons or overlap them in my vision field or field of vision. So if you can do that, that's awesome. I'm impressed. Yeah, Tiffany, you're more like me in that respect because I find that a challenging thing. But overall, these questions are much more clear what you need to do, and it's a lot more straightforward to do them. The next kind is what I call hole punching rather than paper folding, because honestly, the hole punches is what's more important in the grand scheme of things with these questions. Because what they'll do is they'll show you a series of folds and then they'll punch a hole in the piece of paper. And what you need to do is predict where the holes will be in the unfolded piece of paper when you unfold it again. And this is something you can physically practice. So I would get yourself some, like, you can use Post-its. Post-its are great for this because they're square, and you can get yourself one of those hole punches. And so when you're doing practice to get good at this, it doesn't hurt to like do the folds like they're showing, punch a hole and see what it actually does. So you can get that feel for how it does it. I personally do this by unfolding in my mind's eye. So if I unfold this, I've got a hole in here. When I open it back up, where am I going to have a hole? So that means I put together a grid of my own. So what I do is I draw a new grid and I say, okay, after with that original hole, I got one right here. Now, if I unfold it, where am I going to see another new hole appear? Above it, below it, to the left, to the right. So I'm just doing one unfold. I'm going to unfold this. Well, I see another one up, down, to the left, or to the right. down. And since it's right near the fold, is it going to be all the way at the bottom, or is it going to be somewhat centered? It's going to be somewhat centered since it was near the fold. Okay, so already B is out, C is out. We can say that. All right, then the next fold, it looks like we're going to take that new figure and we're just going to flip this down. I don't know what's going on with the mouse there. So we're going to flip that down. So am I going to get any additional holes? I should. And which hole is the one that's going to be moving? Is it the top hole or the bottom hole that's going to be moving? The bottom hole is going to move because the top hole is safe. It's above the fold. So the bottom hole is going to move. So is that going to give me one new hole or two new holes? Just one more new hole. What's my answer? How many new holes do I have in A? How many new holes do I have in D? How many new holes do I have in E? So D and E have too many holes in it. It's got to be A. So if you just unfold it backwards from the original hole punch and just sort of map it out as you go, these aren't that bad actually. Again, you can practice these physically as well, which means you can get really good at doing these types of questions. All right, the next kind of question is called painted cubes or cube painting. And honestly, out of all of them, I feel that these are probably the easiest for most people. And there's just basically, you can't ever paint the bottom, and you would paint only the surfaces of the rest of the cubes. And there's usually 3 or 4 questions that go with one set of blocks. So one of the easiest things you can do for these questions is just create yourself a tally of the number of painted cubes. So on your scratch paper, just write 0, 1, 2, 3, 4, 5. There is no 6. You can never paint the bottom. And then go through and tally up all the cubes that you should be seeing and make sure they add up to the right number. So are there any cubes here that are completely hidden and not going to be painted? Is there anything in the middle of somewhere that has a block on top of it and a block on all other 4 sides? It's also kind of like Minesweeper, by the way. Great game. Looks like we're struggling with that one. Okay. How about, let's start the other side. Are there going to be any cubes that are painted on 5 sides? Yep, there's going to be 4. 1, 2, 3, 4. They sit right on top and just standing right out there. Okay. How about cubes are going to be painted on 4 sides? There's going to be 1, 2 painted on 4 sides. Any cubes painted on 3 sides? Now we got a few different options. I've got 1, 2, 3, that one back there, 4, that one on the corner, 5, this one right here. Two sides, and usually your 1s and 2s and 3s are your most common. Usually 1s, 2s, and 3s are most common. I've got 1, 2, 3, 4, 5, 6 2s. Any 1 sides? Any no sides? Nope. So let's add them up. That's 11, 12, 13, 14, 15, 16, 17, right? Did I count that right? Yeah, 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So make sure you tally it up right at the end to make sure you're good. And now you're all set up for any question they could possibly ask. So what's the answer to the question on the screen? It must be D because there's 6 cubes in my tally that were painted on 2 sides. And there you go. And then there's going to be like 2 or 3 other questions asking for like how many cubes have 3 of their sides painted or 6 of their sides painted. So it's worth the time investment on these to upfront go ahead and do the tally rather than counting them as you go. Because honestly, it's a good check on whether you're doing it correctly or not. If you're doing it wrong, you will find out that your tally didn't add up to the right number of cubes. So it's really just a self-check on the process so that you're not making silly mistakes as you go. Because it can be easy to rush through these, but again, I think personally these are the easiest questions to do out of all of them, just because of it's something that's so much more tangible. But I know people that do find these challenging. So everybody has their own strengths on these. The last kind are called pattern development or 3D form development or pattern folding. And these are like if you had this piece of paper with this design on it, what would it fold into? How would it fold into it? This is where the ever dreaded chirality will come into play. Do you guys remember what chirality is from organic chemistry? Do you guys remember liking chirality in organic chemistry? That's what usually happens. This isn't like chirality like assigning RNS, however. This is chirality in the fact that you can have left-sided and right-handed and left-handed figures, but it's more about just identifying the relative orientation of things. So what I usually do is look at the patterns or the shaded parts first. So I see the shaded part and a pattern. I see the circle and I see that shaded part. Now, the way this is going to fold, I should see the shaded part have a right, like if I fold it, it's going to have a right angle forming where? in the center of this face or at the edge of this face? Where's that right angle going to be planted? I mean, this right angle, this one. It's going to fall at the center part of that face, not the edge part. So that right angle in that triangle should be touching the center of that face with the circle in it. Does A do that? Nope. Does B do that? Yep. Does C do that? Nope. Does D do that? Nope. What's the answer? The answer's got to be B, because it's the only one that puts that shaded triangle in the proper location on that face. And yes, that it's, again, this is a pretty simple example of it, but this is the kind of stuff that's going to help distinguish your different answers from one another. So if those, like, basically that's why they put the features on these things. So they put shadeds, they put zeros, they put O's, they put holes, they put all these other things so that you can start distinguishing like what parts match up with what parts and how is it going to fold together. So there's our sort of straightaway answer to find those things is look at those features and how they match up. Notice how I was like picking on not just the triangle though, because if I just pick on the triangle, I might be tempted by which other answer. A is a tempting answer. A is really tempting because it puts that triangle on that face. What's wrong with it is it's backwards. And this is where the chirality comes into it. The orientation of the left-rightness of that triangle matters. So that's why I was picking a specific feature of that triangle to compare. So specifically the unique angle, which was a right angle. Notice I also didn't go after the 45-degree angles in it because there's two of them, which makes it harder to track position. So looking for the unique feature in these things is what makes it easier to do the questions. So that's how you got to approach them. And I think overall pattern folding can get complicated for some people. Sometimes the features are very, very many. They put a lot of different features in there. So you just got to be careful in tracking. So this is, like I said, this is a more simple example than what you might end up seeing on you know, a full section of questions. But at the end of the day, that's really what you're trying to look for. All right, questions. Because that's it. That's what this section's about. And like the only way you're going to get better is by practicing. This is truly a visual part of the test. There's not much you can do to study how to do these. You've got to develop your eye for the questions and develop your eye for like distinguishing angles and things like that. So that's honestly one of the biggest difficulties of these types of things. To get more practice, there's lots and lots of problems in DT Bootcamp or Crack DAT. That's the place where most people will get practice problems. There's also DT prep books. You're either going to get them from Fretbook or from an online question bank. If you are struggling, you can use actual blocks for this kind of questions. You can use actual paper and hole punch for these kinds of questions. You can, I actually use Legos. I shouldn't say Legos. It's not Legos, it's Lego. I actually use Lego with some of my, like in my DAT students that I've worked with on this, like directly. and like made an object out of Lego blocks and had them take that object and rotate it in space and draw the projections or draw the different keyholes by tracing around it, just so they get better at that. So you can also practice those. The ones I think are just like so hard to practice are these pattern foldings because they're complicated. It's hard to find physical representations of these. But the other ones, you can definitely do physical representations of them in 3D space. That's always a good way to do it. Just think your lucky stars you're not taking the Canadian version of this test, which also requires you to do a soap carving. In fact, the US test used to have you do the soap carving, but then the carvings would get lost in the mail or get crunched or stuff like that. But in Canada, they still require them to carve an object out of a piece of soap.